Okay, so these are all integration by parts questions. So we know that integration by parts is u dv equals uv minus the antiderivative of v du. So generally, it's just all about getting a good choice for both u and dv. So in this question, right, there's a couple of different things we could do. We have u dv, right? So we need a v function, which is going to be the antiderivative of whatever we choose for dv, and then we're going to need to take a derivative of some function u, right? So generally, what we'd want to do is choose something really easy that we can take derivatives of, and also something that we can easily take antiderivatives of. So if we say, I don't know, let's make u equal to x, then du is going to equal just 1 dx, right? So if dv then would have to be the sine of 2x dx. If we take the antiderivative of that, we're going to get 1/2 cosine negative 2x. All right, so then when we plug in what we know, I would say u dv is just always going to be the original function. Right? We would have x sine of 2x dx. Right, so u times v is going to be negative 1/2 x cosine of 2x minus the antiderivative of v du, this right here. Right, so we would ask ourselves, is this something that I can easily take an antiderivative of? And indeed we can. Right, so we're going to get a negative 1/2 cosine 2x dx. Right, so when we take this antiderivative, right, I can combine those two things to say plus 1/2 antiderivative of cosine of 2x dx. And when I take the antiderivative of the cosine of 2x, I'm going to end up with the sine of 2x times another 1/2 plus a constant. So we're going to get our antiderivative as this thing, negative 1/2 x cosine 2x plus 1/4 sine 2x plus a constant as our answer.